Welcome back. This is Mr. Hassan's Maths channel. I'm now answering a question from the February-March 2023 IGCSE Cambridge Paper 2, Variant 2. This is the 0580 syllabus. This question here is about angles in circles, and it tells us about ABCD, and they told us that ABCD is a cyclic quadrilateral. So they don't actually have to say that to us, but they've told us that, which is going to help us. So A, B, C, D is a cyclic quadrilateral, and there are some special properties that cyclic quadrilaterals have that we're going to be using. So ABX is a straight line. ABX is a straight line. That's also important to know that. And PQ is a tangent to the circle at A. Again, that's very important. So tangent to the circle at the point A. Angle CBX is 85 degrees as marked. Okay, CBX. Angle BAQ is 55 degrees. BAQ here. That's the angle between this tangent and this chord, which is again important. And CAD, this angle CAD is 42 degrees. We've got to find all these angles here. So let's start with the first one, CBD. So let's first identify where the angle CBD is. CBD is the whole of the angle over here, this angle here, CBD. Now, when you want to find an angle, all right, you got to find CBD. One of the things that will really help you a lot in this type of question, okay, is if you look at the angles they've given you, can you see the same letters on both ends of any of the angles they gave you? So here I can see that you've got CAD, right? So I have, on one end I have a C, the other end I have a D. CAD. And this is CBD. All right, so these two angles must come from the same arc. Okay, so if you follow them back, so if we take CBD and let's follow CBD to where it starts from. Okay, so I'm just going to make this a bit thinner so it doesn't. So CBD, if the angle CBD is here, if you take this arm of the angle, it takes you back to C. You follow this arm of the angle back, it takes you back to D, CBD. So that's CBD. Now we can see that the angle CAD also, this angle goes back to C, and it also goes back to D. So they both originate from the same arc. They're both standing on or subtended by the same arc. So that means this must also be 42 degrees because it's standing on the same arc as CD. So angle CBD is equal to angle CAD. As we can see, they're both standing on the same arc. All right, and they're both on the circumference. So this is going to be equal to 42 degrees. You can say angles, they don't have to give a reason, but I'm just going to do, just for your completeness, angles on the same arc. Something like that would be fine. Okay, so this is 42 degrees. There's the answer to part A. All right, now for part B, it says angle ACB. Angle ACB. So let's first mark the angle ACB. Okay, that's ACB. So it's the angle over here. Okay, now we don't have any other angle directly given to us which has got A and B on either side. Okay, so we got to think of another way of dealing with this. However, let me just get rid of some of these. In fact, I'll just get rid of them. Have I got rid of answers there? I did. 1 second. I don't want to get rid of that, do I? Okay, so now what I'm going to do is just get rid of these markings here so that I can carry on and answer the question. So we know now that this angle is 42 degrees. That's what we just found. Okay. Now, CBD is this angle over here. The angle we're looking for now is angle ACB. ACB is the angle over here. So we have to try and find this angle. So with this topic, there's normally lots and lots of different ways of finding angles, right? I'm just going to, I'm going to see whatever comes to my head. Now I can see that this angle, I can see that angle ACB is the same angle as angle ADB. Okay, angle ADB. Again, they're starting from the same A and B, right? So ACB and ADB are the same angle. So this angle is the same as that angle. So if I can find this angle, then I will be able to find this angle. And one of the laws that we learn is that when a tangent meets a chord, the angle that's formed between them, which is this angle 55, the angle between this tangent and this chord, is the same angle as the angle that is made by the chord on the opposite side of the circle. So the angle standing on the chord, which is this angle over here, okay, is equal to this angle. So these two angles are the same. Okay, this angle is the same as the angle, so that's 55. That's using alternate segment theorem. There might be other ways of doing it, but that's the way that comes to my mind directly. All right, so yeah, so this angle here is 55 degrees, and if this is 55, that's 55. So we can say that angle ADB is equal to 55, and you can say alternate segment theorem. Okay, and then you can say that therefore angle ADB, okay, or what we're looking for is angle ACB. Okay, and we can say therefore angle ACB is equal to 55 as well, because they are angles on the same arc. Angles on the same arc. This is on the same arc as ADB. Okay, so ACB is equal to 55. So we've determined that ACB is equal to 55 degrees, the same as this angle over here. So that's 55, and that's 55. Let me just make that a bit neater. Okay, so they're both 55. Okay, and the reason why they were 55, because this is 55. These two angles are the same. And because these are on the same arc, these are also the same. All right. Now, let's continue. It says angle ADC. ADC. So ADC. So it's the whole of this angle here. Okay, now, this is where I think the cyclic quadrilateral bit comes in. This is the cyclic quadrilateral. The cyclic quadrilateral goes, it's like A, B, C, and D. This four-sided figure is a cyclic quadrilateral. All right, so therefore what we can say is in a cyclic quadrilateral, the opposite angles are supplementary, but the angle that's opposite to an exterior angle, this exterior angle, these two angles must be the same, because this whole angle here plus this angle here add up to 180, and these two add up to 180 as well. So this must be the same as that. So this must be 85 degrees. So angle ADC is 85 degrees. Okay, 85 degrees. You can say that angles in a cyclic quadrilateral. Okay, to be more precise, we would say that the opposite, the interior angle is equal to the opposite angle, the opposite exterior angle in a cyclic quadrilateral, something like that. But that's fine. We don't have to write any reasons for this. Then it says angle BCD, 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 which is the whole of this angle over here. Okay, now I can think of, let's think of different ways of doing this angle here. Well, a way comes to my mind is this angle. We can say angle BCD is what we were trying to find. Is it BCD? Yeah, BCD. We can say that BCD is BCD, okay, is opposite this angle here. Okay, it's opposite this angle here. Okay, so we can say BCD plus, we can say DAB. They must add up to 180 because they're opposite angles in a cyclic quadrilateral. They add up to 180 degrees. Something here, it's going all messy. They add up to 180 degrees. Okay, so opposite angles in a cyclic quadrilateral add up to 180 degrees. And I know that this angle here is 30 degrees because this is 85 and this is 55. 85 minus 55 is 30. So we can say the angle CDB is equal to 30 degrees. Okay, and I know that this angle here is the same as that angle there because CDB and CAB are both on the same arc CB. So we can say that CAB must also be 30 degrees because they're both standing on the same arc, as we can see, and then, both on the circumference of the circle. So this is 30 degrees, which means the angle here is 72 degrees. The angle DAB, that means DAB is equal to 42 plus 30, which is 72 degrees. So now I know this is 72, so we can follow this further. So BCD, okay, is equal to 180 minus DAB, which we worked out 72. So 180 minus 72 is going to be 108 degrees. Okay, 180 minus 72 is 108 degrees. So that's the angle BCD. BCD, 108 degrees. Okay, so we've got the angle over there. And then finally, we've got to find angle PAD. PAD, where is PAD? PAD is this angle over here. Okay, again, we could use the fact that we have a tangent meets a radius. Okay, so no, actually, what's easier here, actually, because it's going to be the same as this angle. We don't know the angle. I'm sure we can find it easily, but I think what's easier here is PQ is a straight line. So these angles together add up to 180. So we can say the angle PAD is equal to 180 minus the sum of these angles, which is 72 plus 55. 72 plus 55, because that's 72 plus 55, and that should give us the answer to that. So that's 180 minus, that's going to be 127, which is going to be 3, that's 30 plus 5, 53 degrees. So angle PAD is therefore 53 degrees. And there we have the answer to this question. All right, so that concludes this question number 17. It's a bit involved, but we have to follow the rules of cyclic quadrilaterals, angles on the same arc, alternate segment theorem. There could be other ways of doing these questions, by the way. There's normally more than one way of finding answers, but these are the ways that hit my eye first, right? So anyway, so this is one of those topics where there are alternative ways of answering them. And if you saw things in a different way, that's fine. All right, now, as long as, of course, we get the right answer. Now, other questions from this particular paper will be found in the playlist that will appear in this region over here. Other questions from this topic of angles in circles will be found in the playlist over here. You can subscribe to my channel by clicking on this link, and you can watch the video here, which will take you to the playlist or will take you to the playlists for different parts of my IGCSE syllabus, so you can find things easily. Thank you for watching, and see you soon.